In order to relate concentration and density, we are finding the density of 5 milliliters of the given 20% concentrated stock solution. A stock solution is a concentrated solution that will be diluted to a lower concentration. Here, Franz is measuring the 5 milliliters of stock solution. This is an example of a meniscus, which is curvature of the upper surface of a liquid caused by surface tension. In this case, the curvature is concave up. It is measured by lining up the bottom of the meniscus as shown on the right. Here we are measuring the mass of the 5 milliliters of stock solution. Once we subtract out the pre-weighed mass of the beaker, we get the mass of the 5 milliliters. We then take that mass, divide it by the 5 milliliter volume, and get a density of 1.06.
Here we are creating a dilution of the stock solution by adding 5 milliliters of blue water. This will give us a new density and concentration. Once again, we are measuring our dilution to get its mass. We are now taking that mass and dividing it by the volume of 10.01 milliliters to get a density of 1.02 grams per milliliter. Now we are using the dilution equation to find our new concentration. This equation is essentially a proportion equation and will be elaborated on later. Adding 5 milliliters of water is giving us a 9.99% concentration. Now we are creating a new dilution by adding another 5 milliliters of water.
Once again, we will weigh the dilution to get a mass of the dilution. Here we calculate the density by dividing the mass by the volume. We get a density of 1.01. Again, we will use the dilution equation. Here, 100 is divided by the volume of 15 milliliters to get a 6.67% concentration. Again, we were creating another dilution. However, because of the minuscule changes in density that we were seeing, we decided to add 10 milliliters of water instead of 5 milliliters. And now we weigh it again. Obviously, there was a larger mass increase this time.
We then use the mass over volume calculation to get our density of 1.0. Here you see the dilution equation relates the original solution we were given, or the stock solution, to the dilution we just made by proportions with respect to the volume. Here we get a 4% concentration. Now we will draw a graph with density on the x-axis and concentration on the y-axis, and plot all of the data we have collected thus far. This will help us determine the concentration of our unknown solution. Here we are measuring out 5 milliliters of our unknown concentration solution. Once we find its density, we can use the graph we made to estimate a concentration. Here we weigh the dilution to get its mass. Now we divide the mass of 5.122 by the volume of 5 to get a density of 1.02. This is almost the same as our second data point. Therefore, we conclude that the concentration of unknown 242 is around 10%.